Hey, it's Mrs. Weethy back for Lesson 6 on limiting reactant and reactant in excess. Our learning goals for this lesson will be that will be able to determine the limiting reactant when you're given the quantities of both reactants in a reaction. You'll be able to use the limiting reactant to determine the quantity of products. And then you will also be able to figure out the amount of excess reactant that remains at the completion of a reaction. Okay, so you might wonder what a limiting reactant is. A limiting reactant is one that is completely used up in a chemical reaction. Once it's gone, the reaction stops and there's no more product that is made. So it controls the amount of product produced in a chemical reaction. It's very important, and you have to figure that one out. It's always the reactant that's used in a stoichiometry problem because it's the one that controls how much of the other reactant is used and how much of the products is actually being produced. The excess reactant is exactly what it says. It's not completely consumed in the chemical reaction, so you're going to have some left over. It does not determine the amount of products. That's the job of the limiting reactant. All right, so let's take a look at a problem. We have potassium superoxide is used in rebreathing gas mask to generate oxygen. This is the chemical formula or the chemical equation for this reaction. So there's two parts to this problem. First, we want to find how many moles of oxygen can be produced from 0.15 moles of potassium superoxide and 0.10 moles of water. Then we want to determine the limiting reactant. First, copy down the balanced equation. Then you want to put in what you know. So we know that we have 0.15 moles of potassium superoxide. We also have 0.10 moles of water. Well, that presents a problem. Our unknown is the moles of oxygen. And our problem is that we have two starting amounts. We have the amount of potassium superoxide and water. So which one do you choose? You can't just randomly choose one. You have to figure out which one is going to be completely used up in your chemical reaction. So choose one. Doesn't matter which one. Choose one and convert it to the number of moles of the other reactant. So I always start with the first one that's in the reaction in the chemical equation. So I have 0.15 moles of potassium superoxide, and using the mole ratio, I'm going to convert that to moles of water. 2 moles of water over 4 moles of potassium superoxide. Divide out your common units, and that gives us 0.075 moles of water. So what does that mean? Let's analyze. So this is what we have, 0.075 moles of water. We want to compare that amount. That's the amount that's required to react with 0.15 moles of potassium superoxide. You want to compare that amount, the required amount, with the amount that you actually have. So we have 0.075 moles of water. We actually have 0.10 moles. Which is more than enough. That's more than what is required. So if you have more than what is required, then that is your reactant in excess. That's going to make our other reactant, potassium superoxide, the limiting reactant. So if you have more than enough, that's an excess. If you don't have enough, then that will be the limiting reactant. Let's see what would happen if we would have chosen water and converted to potassium superoxide. So we're going to do that just so you can see what I mean by not having enough. All right, so I'm going to take my moles of water. I'm going to convert that to moles of potassium superoxide using the mole ratio. Divide out the common units. That gives me 0.20 moles of potassium superoxide that is required. I need this much to react with 0.01 moles of the water. So, do I have enough or not enough? Compare the two amounts. 0.20 moles is what's required. Our actual amount is 0.15 moles. So we have less than what is required. Therefore, the potassium superoxide is going to be the limiting reactant. So you always have to compare that required amount to the actual amount. If the actual amount is more, then it's an excess. If that actual amount is less, like we see here, then it's limiting. So now that we have the limiting reactant, we can now solve part B. So we solved part B. We found the limiting reactant. So we actually had to do part B before we can actually solve the problem in part A. So now we're ready to do that. We need to use the limiting reactant to find the moles of the oxygen. So we're starting with 0.15 moles of potassium superoxide to get the moles of oxygen. Plan moles of potassium superoxide to moles of oxygen. Set up your problem using the mole ratio, and that will give us 0.11 moles of oxygen that is produced. Now our problem is complete. All right, so, there's good old Dora. Excelente. So now you try one, and I will guide you through it. Okay, so you can stop this anytime that you need to stop and solve the problem. So here's the problem. Reaction between solid white phosphorus and oxygen produces solid tetraphosphorus decaoxide. This compound is often called diphosphorus pentaoxide because its empirical formula is P2O5. First, determine the mass of tetraphosphorus decaoxide formed if 25.0 grams of phosphorus and 50.0 grams of oxygen are combined. Then you're going to calculate the amount of excess reactant that remains when the reaction stops. Where do you begin? Start with part A, and you have to find the limiting reactant. So write a balanced equation for the reaction and organize what you know. So pause your video and write the balanced equation. Okay, now that you're back, here's the balanced equation you should have come up with. All right, put in what you know, 25 grams of phosphorus, 50 grams of oxygen, and the number of grams of P4O10. All right, so you have two reactants. You have to find the limiting reactant next. Okay, which one are you going to use to find the number of grams of P4O10? So pause the video, and I want you to find the limiting reactant. Okay, now that you found the limiting reactant, let me go through the solution so you can make sure that you did this right. You're converting both reactants to moles first. And here we have grams of P4 to moles of P4. You get 0.202 moles of P4. And then you're taking grams of oxygen, convert that to moles of oxygen. Next, convert one of your reactants in moles to the other in moles. So I started with P4. 0.202 moles of P4, mole ratio to oxygen. That gives us 0.101 moles of oxygen. Now you have to compare. That's your amount required. The amount that we actually have is 0.156. So the amount required is actually, or the amount that you have is more than the amount required. That makes oxygen in excess. P4 is the limiting reactant. All right, now that you found the limiting reactant, you can now find the number of grams of P4O10. So pause the video and do your stoichiometry problem using your limiting reactant. All right, now that you have found it, let's go through. It's your plan. And here's our solution. So you should have gotten 57.3 grams of P4O10. There's Dora. Excelente. Now you can do part B. So here's part B. How much of the excess reactant remains after the reaction stops? Where do you begin? You want to start with the amount of oxygen that is required. So remember that you converted both reactants to moles first. This is what we did. Next, we determined that oxygen was in excess. Now that you did that, you know that oxygen is in excess. You can find the amount of oxygen that is in excess. So let's see how you do that. Take the actual amount, subtract the required amount, and that gives you the amount in excess. But that's in moles, so you want to convert the moles of oxygen to grams of oxygen. And we get 17.6 grams of oxygen in excess. Now the problem is complete. And this completes Lesson 6 on limiting reactants and reactants in excess. This is Mrs. Wheathy. So long for now.